Say you walk from your home to the market. As you move, you cover a certain length, which is defined as the distance. And in this case, 70 meters is the distance between our home and the market. Now, what is displacement? Displacement is the shortest distance between our home and the market. If we look at the figure closely, we can see that this path forms a right angle triangle. Thus, we can calculate displacement by solving for hypotenuse using the formula c squared equals a squared plus b squared, where a is the base of the triangle and b is the perpendicular and c is the hypotenuse. Inserting the values, we get c squared equals 2500. C equals square root of 2500, which is equal to 50 meters, much shorter than actual distance of 70 meters. The other difference between distance and displacement is that distance is a scalar quantity, which means it only measures magnitude, while displacement is a vector quantity, which includes both magnitude and direction. So when talking about displacement, we also need to mention its direction. Therefore, the distance is 70 meters and the displacement is 50 meters northeast. Speed is the ratio of the distance covered by the object and the time it took for that motion. It is also defined as rate of change of distance. Let's say a car is moving on a straight road. Can you state the type of motion it is undergoing? Since it is moving in a straight line, it is called rectilinear motion or linear motion. Suppose the time it takes to reach the other side is 30 seconds. Now consider another car which is similar to the first one. It is also moving in a straight path adjacent to the first one. The time taken by this car to cover the same road is 40 seconds. The blue car covered the length in 30 seconds, while the red car covered the same distance in 40 seconds. Which one of them was moving with greater speed? By intuition, we can say the blue car was traveling with greater speed because it covered the same distance in lesser time. Let the length of the road be 420 meters. This length is the distance between the start and end point. Now, for each car, if we take the ratio of the total distance covered to total time, we get the below number. This ratio is called speed of the object. So, to recap, speed is distance over time. As 14 is greater than 10.5, we can say blue car travels at a greater speed. Let's bring in a third car, which covers the same distance in 20 seconds. So, what is its speed then? The speed is 420 meters divided by 20 seconds, equal 21 meters per second. This ratio is greatest of all. Now look at the units, meter per second. It is one of the units of speed. There are other units of speed as well, such as kilometers per hour, miles per hour, feet per minute, and so forth. At your level, the most important ones are meters per second and kilometers per hour. We already know how to calculate the speed of an object moving along a path. Speed is the ratio of distance traveled by the object to the time taken to complete that distance. Suppose the distance the car travels d is 20 kilometers and the time it takes to cover this distance is 4 hours. What will be the speed? The speed will be 20 over 4, that's 5 kilometers per hour. Does this number indicate that the object travels 5 kilometers every hour? If this is true, can we say that the speed of the object is constant? If the speed is constant, then it means the car will cover 5 kilometers every hour. In other words, the distance covered per hour will be 5 kilometers. In reality, we know that this is not the case. When a car starts, it doesn't automatically start at 5 kilometers per hour. Its speed gradually increases over time. So if the car was traveling at this point, then speed cannot be constant. Probably the car was slow in the first half of the journey and sped up in the second half. The given data does not stipulate that the car covers 5 kilometers every hour. So if this speed is not constant, then what it is called? It's called average speed. Average speed is defined as the total distance covered by the object over total time taken. In this example, we are given a total distance and total time taken for that distance by the car. Hence, we calculated an average speed for the entire journey. It is important to be clear about the concept of average speed. The unit of speed in this example, kilometers per hour, also known as kpmh, and it's one of the most common units of speed. Let's say a car is traveling from point A to point B, and the speedometer shows these values at these instances. At time t2, the speedometer reached 30 kilometers per hour. What does this mean? Is this an average speed? No, the speedometer shows us the instantaneous speed, which is the speed at that instant of time. Here, speedometer reached 30 kilometers per hour. It means at that moment of time, the car is traveling at that speed. It does not say the car has been traveling at this speed or will travel at that speed. The value is only at that instant. That is why we see the pointer on speedometer is never really constant. It keeps fluctuating. Consider 2 points, A and B, with A being the starting point and B being the ending point. Blossom moves from point A to point B, and as she moves, she covers a distance of 20 meters. She took 10 seconds to cover that distance. Her speed is the ratio of her distance to her time. So 20 divided by 10, her speed is 2 meters per second. Now, if we consider the displacement, which is the shortest distance between starting and ending point, her displacement is also 20 meters. As her path is a straight line, distance and displacement are equal. Her velocity is the ratio of displacement over time. So her velocity is 20 divided by 10. In other words, 2 meters per second. As you can see, both speed and velocity are 2 meters per second. They have the same magnitude. But in case of velocity, we also need to consider the direction. As she is moving from A to B, her velocity is 2 meters due east. So in this case, both speed and velocity have the same magnitude. However, for determination of velocity, we must also look at the direction of motion of that object. Say the distance traveled was 70 kilometers in 100 seconds in our previous example. Speed refers to rate of change of distance. The equation can be written as speed equals distance divided by time, which would give us 0.7 meters per second. Velocity, on the other hand, is the rate of change of displacement. In this case, the displacement is 50 meters covered in 100 seconds. Velocity is calculated by dividing displacement over time. In our example, this would yield 0.5 meters per second northeast. Don't forget to write the direction as velocity is a vector quantity. So velocity can be same as speed but also different due to changes in direction. Imagine Powerpuff Girls running away from Mojo Jojo. They run in different directions but with the same magnitude, 4 meters per second. As the magnitude is same, we can say they run with same speed of 4 meters per second. But can we say they have the same velocity as well? We know velocity is a vector quantity, so we need to consider direction as well. All of them are moving in different directions as indicated by the dotted arrow line. Even though magnitude is same, but direction is different. Hence, velocity of every Powerpuff Girl is unique.